Hello, welcome to a new video about using FreeCAD to generate G-code for your CNC. In this video I'm going to show you a couple of tricks that will help you achieve a much better surface finish in a few situations. For example, for pockets, for profiling, for making round holes using the Helix operation. But before getting started, just a moment to thank you all for watching my videos, sharing them, liking them, commenting on them. Be it good or bad comment, it helps me a lot. And of course to thank you to all my supporters through my Patreon page. If you want to subscribe, you can find the link in the description. If you don't feel like subscribing, you can buy a one-time small thanks, a $3 thanks, or a big thanks, a $10 big thanks. So thank you all for all the support and all the help. Now let's move on to the tricks that I want to show you today. The first trick is getting a very smooth finish pocket. I want to mill this pocket and I want it to very smooth on all the sides. So let's select the face, let's create the operation just as we normally do. Here are a few settings that also impact the quality of the finish. For the cut mode I have two options, a climb cut and a conventional cut. They both have advantages and disadvantages depending on your machine, on its rigidity, on the spindle, on the cutter tool bit of course. I usually tend to use climb cut because I'm milling mostly wood, and conventional cut tends to tear up apart, to splinter the wood. Climb cut almost never splinters the wood. So if you are using your machine for woodworking, climb cut is the way to go most of the times. I will show you some situations when also conventional is a good thing because it will result in a better finish, but we'll get there in just a couple of moments. So I will leave the cut mode to climb. The pattern, if I leave it to zigzag, let me just press the apply button. You can see that the toolpath has a lot of portions of the pocket where it simply doesn't cut, so it will leave a very bad finish. Let's change to zigzag offset, which does exactly the same thing, but after making the zigzag it will cut an outline, so you will get a smooth finish for the walls of the pocket. Whenever you need a pocket with smooth finish, you can use zigzag offset instead of zigzag and the walls will also be milled. I have another pattern that I use very often, it's called offset. This means that it will take the shape of the pocket and keep on milling by reducing the size until all the pocket is milled. This most of the times works great. It has some little bugs. If you see here I have a step over of 100%, but if I set a top view, let me change it to orthographic so we can easier see. There are many lines in the center which don't respect the 100% step over. There is a reason for that, but I'm not going to talk about it right now. Let's fix this. Let's change the step over to 90%, click on apply again, and you can see there are a lot less toolpath with a slightly better result because a 90% step over will result in a better final piece comparing to the 100% step over. So if you feel like there are too many lines when using offset, try changing the step over slightly higher, slightly smaller until you get the optimal number of lines. Of course, huge difference for the final finish of the bottom of the pocket. It doesn't affect the walls, but the bottom will be affected by the step over percent. If I want some passes that are closer together, I have to reduce the value of the step over. So a step over of 50% will make more lines, but the finish will be smoother depending of course on the situation and on the material. So I've explained what these options do and how they impact the quality of the cut. Now let's close this dialog and take a look at the operation, and now let's make the final optimization, which is composed of two parts, because whenever you're milling a pocket you have to remove a lot of material. So mostly the parameters for removing the material will be pretty high. Toolpath with a big distance between them, a step down as big as possible because you want to do things fast of course. But after milling most of the material you want to get a smooth finish. How do you obtain that? For the bottom face it's pretty easy. Open the pocket shape operation, go to the depth tab, and here you have an option finish step down. If you set this to a value, let's say of 0.2 millimeters, after milling most of the material you will see a final path with a very little step down, which will result in a much cleaner cut, a much smoother surface. So remember, whenever you want to get a very smooth bottom face, you have to change this value finish step down to 0.2 millimeters. Unfortunately, this option doesn't take into account the walls. We have to solve that somehow. Let's go to the operation tab, and here I have another value, pass extension. I will also use 0.2 millimeters. It will shrink a little bit, even though in my opinion setting a positive pass extension means it should pass the extension and create a little bit larger toolpath, but here the positive value for the pass extension actually shrinks the toolpath. And now after setting this pass extension to 0.2 millimeters, I can click on OK and the pocket will be slightly smaller, which is a good thing because now I can select the bottom face, create a profiling operation this time. First I will close this profile operation in order to be able to hide the pocket shape so you can see better what I'm doing. So let's open the profile operation. As you remember, we have milled everything except the last 0.2 millimeters. So we can safely go to the depth tab and use a step down equal to the total cutting height of the tool bit, because it will mill just a little bit of material so you can engage the whole height of the cutter. This will mean much less lines and a smoother finish. My tool bit has a 15 millimeters cutting height, so I will set a step down of 15 millimeters, and you can see it's just a single pass, which means these four walls will look almost perfect. One thing that I need to change, and I've told you at the beginning when explaining about the climb cut and the conventional cut, is the direction. I will change the direction to conventional because conventional tends to leave a smoother surface. If the material has some issues, you might want to change it to climb cut, but most of the times conventional is the way to go when you want to obtain a smooth finish. So now I will click OK. Let's re-enable the pocket shape operation, and now I have the pocket milled in two parts, which doesn't matter because the G-code will be exported in just a single file if you don't set some export options to export each operation into a separate file, but otherwise it will simply run the pocket shape, then make another pass to run the profile, and you will get the smooth finish that you want. One thing to take into account is that when milling this profile operation at the end, you might get some lines on the outline. Depending on the machine, the cutter head might not be exactly in the same position as it was when making the pocket shape finish, and in this situation, if you have this problem, if the profile will leave some lines on the outline, you can do another little trick. Go to the profile operation, go to the depth tab and change the final depth. Subtract a 0.01 from the final depth. Don't forget to write millimeters because otherwise it will issue a unit mismatch error. Click on OK. Now the profile operation will be slightly higher. Go to the pocket operation, go to the depth tab and remove the finish step down, set it to 0, but also change the final depth to 10.01. And now let's make that final pass because I want to remove most of the material using the pocket shape operation. Then I want to cut the outline to get a smooth outline. Using the profile operation, don't forget for the pocket to set the pass extension to a small value in order to leave some material for the pocket operation to remove. And now I want the bottom to be very smooth after milling the profile in order not to get the line on the outside. So select the face, create a mill face operation, set a step down equal to the total depth of the pocket, which is the start depth minus the final depth. In this situation it is 15 millimeters, but I can also write start depth minus final depth here at the formula, and no matter how I change these values, the step down will always be updated for this kind of operation. Click on the apply button, and now let's go to the operation tab because there still are some settings that we want to change. Boundary shape has to be face region, otherwise if you have two faces it will simply go through the material, which is something that you don't want. Change the pattern from zigzag to offset. The step over of 50 should be okay. Now I can click on apply. Click on OK. Let's hide the other two operations for a second, and you can see I have one final pass for the bottom face to make it smooth, but it's still not okay because it has a lot of lifting of the cutter head. When lowering the cutter head, you might also get a little hole here when it touches the material, so let's reduce those liftings and lowerings of the cutter head. Select the mill face operation, scroll down until you get to the keep tool down option, set it to true, and now I only have one lowering of the cutter head when starting the facing operation. So even if it might sound a little bit difficult, a little bit complicated, splitting the pocket shape operation in 3 operations will result in a much better surface. Whenever I need very smooth pockets, I can use this method. I can make a final pass on the outside with the total cutting height of the tool bit engaged, because it's just a little pass, and after making all of that I can mill the bottom of the pocket. In my situation on my machine, the last operation, the mill face, is not really necessary because the Z-axis is pretty stiff and the profile operation won't leave too many grooves, too visible grooves on the outside. One more little thing that you need to know about the pocket shape operation and about optimization of the pocket shape operation is about the situation when you have open pockets, which mean a pocket that doesn't have all the sides closed. So let's make a pocket operation for this one. Change the pattern to offset, change the step over to 50%. I will click on apply. You can see a very nice operation. Of course I have to select it and scroll down to keep tool down and min travel, change them to true. Depending on the material, sometimes you might want to leave them as they are with false. For example, when I'm milling acrylic, I prefer not to change the keep tool down value because lifting the cutter head from time to time lets it cool down a little bit and avoids melting of the acrylic and damaging the cutter head and of course the workpiece. But in most of the situations the keep tool down value can be kept to true. Now everything will be much faster. If I want smoother finish, of course I can make the same thing that I did earlier with the other pocket. I'm not going to do it now, but I'm going to show you something that is very important. If I set a top view, you can see that the cutter head will stop here. If you imagine a round cutter head here, you will realize that you will have a small round over at the end of the pocket, which is something that of course you don't want. You have 2 options. If you don't use the profile operation, the additional profile operation, you can simply edit the pocket operation, go to the extensions tab and check the enable extensions, and in this list you have some edges that can have extensions. If you click on them, you can see some yellow highlighting here. I will check this extension, and when I click apply, you can see that the cutter head will take into account the entire face, the original face and this extension. It will join them together into a single face and it will mill that face, which means the cutter head will get to the end of the sides of the pocket, so the little roundover from the end of the sides won't be there anymore. You don't need to do this in one situation. If you're using the profile optimization, if I'm going to the pocket shape operation, set a pass extension of 2 millimeters, 0.2 millimeters, and then I select the top lines of the pocket, click on the profile operation. If I click apply, nothing will happen because I have to go to the depth tab, select the bottom face and click the arrow next to final depth. Click on the apply button. Now let's change the step down and set a value of 15 millimeters, the total cutting height of my tool bit. Click on apply. Now let's hide the pocket a little bit, and you can see that the profile by default cuts all the way from the corner, so it's not necessary to set up the extensions anymore because it will result in a lot of useless cutting all over this edge, moving farther away from the body, so that's useless. If I'm using the profile finish, setting the extensions has no point. What's important about setting the profile operation for this kind of pockets, for open side pockets, is that you have to select the lines for the profile and manually set the final depth. If you somehow select the bottom lines, let me just show you. I will open the profile, go to base geometry, click on clear to remove everything. If I select the bottom lines by holding Ctrl down and clicking on them, click on the add button to add them to the base geometry, I will click apply. There's no toolpath generated, even though the depth is correctly set. For some reason it doesn't work. What I found out always works is changing the final depth from the value that I want. Simply add plus 0.02 millimeters. I know it's not the best way, and for some certain situations it will mess things up, but most of the time a difference of 0.02 millimeters is not a big thing. Click on the OK button. Now you can see the toolpath is correctly generated, so this is something that you always have to remember. When the profile doesn't create an enclosed toolpath, you will have to change the final depth to add a 0.02 millimeters to the value and everything will suddenly work. Click on the OK button. You will also get some errors here whenever profiling open edges, but if you see the toolpath, everything should be okay. So let's move on to the next situation. I will delete all these operations to be easier to see. Now let's move on to the next tip that I want to show you. It is about making round holes using the Helix operation. a lot of situations where you need a round hole of a certain dimension, and if you want, for example, to fit a roller bearing inside one of these round holes, to get the perfect final dimension is critical. So let's create a helix operation. Even though I have selected a face, it doesn't take that into account. By default, it selects all the round holes of one face. So let me just delete the second one. Now it has selected the edge, not the bottom, but it also works if you select the bottom. I'm not going to talk about the depth and the heights, it's the same thing as always. Let's go to the operation setup tab, where I have the following options: start from and direction. The direction, as you know, means cutting along the movement or against the movement. In general, I have noticed that a climb cut tends to leave a smaller diameter hole, a conventional cut tends to leave a slightly larger diameter hole, but that is valid when I'm milling with the central part of the pocket missing. I want to tell you what the difference in the final result will be by simply changing this start from value. Start from outside is the default value. It does a pretty good thing, but also a bad thing. Let's go to the simulator. And you can see that with start from set to outside, it first mills the outer part of the hole, then moves on to the inside with a step over, of course, until the entire hole is milled. But what is a bad thing about this solution, let me just move it around. You can see that in the end you will have a tiny little piece here in the center, a tall piece, a piece equal to the total depth of the hole, which sometime might break and damage the cutter, be thrown around. So take good care and only use start from outside when you really need it. When do you really need it? When I want the hole to be the exact same dimension that I have set, I will use start from the outside. Let's change the helix model now from start from outside to start from the inside, and I will open again the simulator to explain why it is a difference between the two ways of milling the holes. As you can see, start from inside will start from the center of the hole, so I won't have that small little piece left over in the center, probably damaging the cutter in some situations. So why shouldn't I use this option? Take a look at the cutter and imagine it's made out of a material and it can bend. If it isn't in the perfect condition and it doesn't cut absolutely perfect, even when it is in perfect condition, this might happen, it will have a little deflection away from the wall that it is cutting. This means it will be slightly bent to the inside, so the walls won't be cut exactly at the correct dimension because of the deflection. If you want to have the perfect dimension for the outer part of the hole, let me just close the simulator, go to the helix, change the start from to outside. And now if we look at the operation, you can see that when cutting, the tool bit has the same amount of material on both sides, which will avoid the deflection, so the hole will have the final dimension correct. So whenever you are having trouble with the final dimension of certain holes, remember the tool bit deflection. The smaller the tool bit, the larger the deflection will be. Most probably the hole won't have the correct diameter. If you want to have the correct diameter, always start from the outside, even though there is a risk for the little bit that remains in the center to be thrown away and damage the cutter head. You simply cannot get the correct dimension using start from the inside. So now let's move to the final trick for a smoother finish. It is about something that I've seen a lot of people complain about, the smoothness on the outside, on the profiling. Let's create a profile operation. I will simply click OK. And you can see I have several passes. Of course it's normal, I have a certain step down, I have to avoid damaging the cutter. Maybe the machine cannot mill too much material at a time, so several passes, it's a normal thing, but just as we did for the pocket, I want to have a final pass with just a little bit of material removed, with the entire active cutter height engaged in the material. So how do I do that? I've shown you how to do it on the pocket operation. Let's do the same for the profile operation. You have an option here, extra offset, and I will set this to 0.2 millimeters. Let's just set a top view so we can easier see how it moves. When I click apply, you can see the toolpath lines have moved to the outside, which means I will have just a little bit of material remaining in order to make the final pass with a step down equal to the cutting height of the tool bit. Let's create that. I will select the profile operation and click on this button, copy the operation in the job. Make sure to change the extra offset back, or if you created a new operation you don't need to change this. Go to the depth tab, change the step down to the value which equals to the total cutting height of the tool bit. In my case it's 15 millimeters. Click on apply. You can see that I have two passes because the material is too tall for my tool bit. But even in this way, if you take a look, I will only have one line here. One more thing that is pretty important when using this method: double click on the profile operation and change the direction from climb to conventional. As I've told you, the conventional cut tends to leave a smoother surface, the climb cut tends to tear out the material a little bit less. When using a 0.2 millimeters engagement, cutter engagement, most probably if you have a decent cutting tool bit, nothing wrong will happen, so changing it to conventional will avoid some vertical lines. If you leave it to climb, you will most probably have some vertical lines from the cutting tool bit movement. So whenever creating profile operations, if you want a smooth finish, set an extra offset and then make a final pass. So that's it for today. I hope this video will help you get much smoother finishes when you need them, and of course in the case of the round holes, to get the correct dimension, the correct diameter, it is pretty important whenever, for example, you want to put a roller bearing inside the hole. If it doesn't fit or if it is too loose, it's a bad thing, so getting the correct dimension is essential. Of course, this depends also on your machine, but regarding the G-code, making it from the outside, as I've told you, most probably will fix those issues of the machine. Don't forget to subscribe to my channel, and if you want to support me financially, go to my Patreon page. You can find the link in the description. Thank you for watching and see you next time.